Check it out. This is a working OR circuit built from scratch using nothing but transistors, resistors, and wires. So we have two switches simulating the digital inputs and a light simulating the digital output. If we plug it in, nothing happens until we press one or the other or both. So let's get into the details of making OR gates from scratch. So what are we going through today? If you want a background on more theoretical topics, see my video on NOT gates where I go into more depth. Well, we'll start with a real-life demo, a working OR circuit with transistors. Then we'll talk about materials that we need. We'll see the truth table that describes exactly how OR behaves. We'll look at the logical diagram in Logisim where we can play around with it. We will look at the circuit diagram in Circuit.js. It'll be a resistor-transistor logic circuit. And finally, we'll look at how to implement the circuit on a breadboard. Before we do, though, this is PageKey, so we have to talk about taking back tech. Basically, the whole world runs on tech developed behind closed doors by big old companies. It's a tall stack of abstraction, and it's very complicated. We rely on those big companies to maintain this stack for us and keep it working. We pay them lots of money because they pay expensive engineers and other people to make that happen. So it is good that they did this because we have great technology from them, and maybe we can trust them to have our best interest in mind. But just in case that we can't, or our interests are not the same or aligned, it's good to have a plan. So if we learn more about tech, which we can do on this channel, those companies have less leverage over us in the long run. That's the big idea. You already saw a sneak peek of it, but let's get a real-life demo of this OR circuit with transistors. So if we want to do a bit of a deep dive on this circuit, you can see we have the two NPN transistors right here. We have the two resistors coming off of the switches or buttons, which are powered. And then we have two resistors on the other side. This gets a little complicated. It's better to look at the diagram. But once it's plugged in, you can just use the buttons to do one, the other, or both, and it clearly matches the truth table of OR. Now, what exact materials do we need to build this? I'll leave some affiliate links in the description just for fun, but we need two NPN type bipolar junction transistors. I'm using 2N222, but it probably doesn't matter which model you use. You need two 1 kilo ohm resistors. Those are right here, brown, black, red, gold. Two 20 ohm resistors are right here. The Arduino and breadboard are not pictured. You need two breadboard buttons. These are our switches. You need an LED. That's right here. And last, you need a bunch of jumper wires, which are all over the place. You don't have to match the color or the size. You can use anything. Now let's look at the truth table for this OR gate. If neither A nor B are true, then the output is obviously false. Otherwise, if either of them, one or the other, in this case one, in this case the other, the output is a 1. And if they both are, that is also a 1. Now let's build this diagram in Logisim so we can play around with it a little bit. So open up Logisim Evolution and go click the OR gate, plop it down onto the map here, and we'll put an input bit, another input bit, and an output bit, and then you can connect them up with wires like so. Click the hand in the top and you can play with the input bits to see what happens to the output bit. And this seems to match what we were expecting. Now let's take a look at the Circuit.js diagram where we built this with resistor transistor logic. Okay, so open Circuit.js and go to import from text. You can find the source for this diagram on GitHub. And once you do, you get this. And we can open and close either of these switches or leave them both on and nothing happens. But the moment that we turn both of them off, the diode also turns off. This is what we are expecting for this gate. So that's about it. So how do we take this circuit diagram and turn it into a real breadboard implementation? Let's start with this 5 volts area. So we're taking the 5 volt pin on the Arduino and plugging it into this top rail so we can feed things off of it. The first two are quite simple. This one here goes to the first switch. That's right here, like so. And the second one goes to the second switch. That is right here. On the other end, we're feeding into the collector of each transistor. So power is directly connected to the collector here and here. Next, we go from the switch through a resistor to the base of the transistor so that you can see out here of the switch into the base of the transistor. And the same thing on the other one. Go out the button through the resistor into the base of the transistor. Now each transistor feeds to a common point down here where two things happen. So let's start with that. The emitter of the first one goes through this little blue connector to here. Row 20. Same thing on this emitter. Comes out, goes on the orange guy, and ends up in row 20 as well. And what else is in row 20? Well, first we have this resistor that just goes to ground. That's right here, and that goes all the way back to the ground pin. And then we have a diode, and then a resistor, and then ground. So that goes on this twisty little wire here, into the diode, through the resistor, to ground. And that's all there is to it. Okay, that's it. That's all I had for this one. We saw a working OR circuit. We reviewed the logical diagram and truth table like good students. We created a circuit design and we used it to implement our circuit on the breadboard so we can feel it and touch it with our hands. If you liked this type of video, subscribe. We're going to take back tech. This is PageKey, and we love rebuilding things from scratch, self-hosting, and many more related topics. So thanks for watching this video. See you for the next one.